In the next several videos, we're going to look at how to prove that triangles are congruent without having to prove that all three pairs of corresponding sides and all three pairs of corresponding angles are congruent. There are several shortcuts. The first we're going to look at is the side-side-side triangle congruence. And what it says is if you know that three sides of one triangle are congruent with three sides of another triangle, then the triangles have to be congruent. So you do not need to know the angles. All you need to know are the three sides of a triangle. Again, this only works with triangles. So in this picture, since we have all three sides marked congruent, then we could make a congruent statement saying that triangle, and I'm just going to do CAT, is congruent to, and then you have to pay very close attention to which order you're going to put the vertices in. C and D are congruent, and then A and G, and then T and O. So triangle CAT is congruent to triangle DGO. CPCTC. So if we know that two triangles are congruent, then we know that all of their corresponding parts are congruent. And that is used in a lot of proofs to prove various properties about quadrilaterals and other things, but mainly in quadrilateral proofs. So instead of writing out corresponding parts of congruent triangles are congruent, we can use this acronym CPCTC. C means corresponding, P parts of congruent, so that's the second C, triangles, so T for triangles, and then R congruent, that's the final C. So you can only use CPCTC if you have proven that the two triangles are congruent. You can't say their corresponding parts are congruent if you don't know that the triangles are congruent. So before ever using this, make sure that you have proven that the two triangles are congruent first. A lot of times this acronym just gets stuck in students' heads and they start using it for everything. It can only be used to prove that corresponding parts of congruent triangles are congruent. So we're just going to look at three diagrams and decide if there is enough to tell if the triangles are congruent based on side, side, side. That doesn't mean that, if it's not side, 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 it doesn't mean that there's not another way to prove they're congruent, but as of right now, we just know side, side, side. So we're just looking at side, side, side. So for A, we have two pairs of sides marked congruent. We've got SA and SI, and then we also have AT and IT. So there's a third side that isn't marked. However, this third side is shared by both triangles. So that's the reflexive property. So these triangles are going to be congruent by side, side, side. And so then we're going to say triangle AST is congruent to triangle, watch the order, IST. If I say AST, I must say IST. Now I could have done SAT and SIT, and there's a lot of different ways we could combine those triangles or name those triangles. All right, for triangle B, so we have two sides given, OB and IB, and then we also have WB and GB. What we don't have is that third side, OW and IG, and there really is nothing there to help us conclude that those are congruent. So these are not going to be congruent by side, side, side. Maybe by something else, but not by side, side, side. So no congruence, or not congruent, however you want to say it. All right, and then finally for C, these triangles are nothing's marked, but there's measurement. So sometimes it's helpful for you to draw the two triangles separately so that you can see them a little bit better. So we have SAE, and it has a side. SA is 9, AE is 6, and then SE is 6 plus 5, which would be 11. So it has 6, 9, and 11 are the three sides. And then we also have that kind of funky sideways triangle WET, We know WE is 11, we know TE is 6, and then we know that TW is 9. So if we compare those two triangles separately, we can see that their three sides all have the same measure. So these are going to be congruent by side, side, side. And so our congruence, I'm going to say triangle SEA. And now that I've made that triangle, I need to be very careful with the second triangle is going to be WET. For example 2, we are stating the third piece of information we need in order to prove that these two triangles are congruent by side, side, side. So what we do know, or what we are given, is SA is congruent to CU. So I'm going to go ahead and mark those. We're also told that SY is congruent to segment CE. So if we're going to use side, 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 that means we need to know these third sides are congruent. And so that would be segment AW has got to be congruent to segment UE. And now we're just going to do a couple proofs. So for our first proof, we are told that PQ is congruent to ST. So I'm going to go ahead and mark that, and I'm going to state that as given. We are also told that QR is congruent to TR. And finally, we are told that R is the midpoint of PS. So if R is the midpoint, what that means is it cuts PS into two congruent segments. So that's going to mean that PR and RS are going to be congruent. So I'm going to make that statement next. PR is congruent to SR. And so now if you look at the figure and the triangles, I have all three sides are marked congruent. So that means we can conclude that triangle PQR is congruent to triangle, we want to make sure we say this correct, PQRSTR. And that would be by the side, side, side congruence postulate. Now, I wasn't asked to prove anything else specifically about these triangles, but now that we know the triangles are congruent, we could use CPCTC, or corresponding parts of congruent triangles are congruent, to prove that any of their angles are congruent. Because the triangles are congruent, even though the angles aren't marked, now we know that the angles must be congruent because the triangles are congruent. So this would be where, if you were trying to prove something about maybe angle P and angle S being congruent, you would use CPCTC. Okay, so for our next proof, we're going to try to prove that triangle JKL, and it looks like my L got left off, so let me add that in, is congruent to triangle NKM. So we are told that JL and NM are congruent, so let's go ahead and mark that. We're also told that K is the midpoint of JN and LM. So if K is the midpoint of JN, what that means is that JN is cut into two congruent segments. So that would mean that JK and NK are congruent. JK is congruent to NK. And likewise, if K is the midpoint of LM, then LK is going to be congruent to MK. And we know that because that is the definition of midpoint. So now if we're looking at our figure, we can see that all three sides of the two triangles are marked congruent. So we do know that our two triangles are going to be congruent by side, side, side. So we've got JKL is going to be congruent to NKM. And again, that's by the side-side-side congruence postulate. So now that we know those two triangles are congruent, we could use that to go further. We don't need to because that's not what we're trying to prove, but we could say anything about any of those corresponding angles. We could say that angle J and angle N are congruent, or angle L and angle M are congruent because corresponding parts of congruent triangles are congruent. For our last proof, we are looking to prove that angle C and angle D are congruent. So what we do know is that AC and AD are congruent. That's given to us. We're also told that CB and DB are congruent, so that's given to us. And then, so we've got two congruent sides, and we're missing this third side right here, but that third side is in both triangles. So we know that AB is going to be congruent to itself because of the reflexive property. So now we have that our two triangles are going to be congruent by the side-side-side congruence postulate. And finally, if we know the two triangles are congruent, then we can say that any of their corresponding parts are congruent. So angle C and angle D are corresponding parts of congruent triangles. So I can conclude that angle C and angle D are congruent because the triangles are congruent. Corresponding parts of congruent triangles are congruent, or you can use that acronym CPCTC. I was only able to use CPCTC because I knew the triangles were congruent. If I had not established that the triangles were congruent, we would not have been able to say that angle C and D are congruent.